Okay, so we're going to carry on now thinking about arithmetic series. So we already know what an arithmetic sequence looks like. That is U1, U1 plus D, U1 plus 2D, and so on and so on and so on. Maybe we could think about those last terms, right? Okay, so if we've got n of them, well, maybe we could think about it as the last term take away 2D, the last term take away D, and then finally that last term. So that is what we understand already about an arithmetic sequence. But now let's start thinking about an arithmetic series. So of course, what would that look like? Well, the sum of those n terms is going to be u1 plus u1 plus d plus u1 plus 2d plus all the terms in the middle, and then those final three terms again. Look, okay, let's write them out so we really understand this. The final term take away two lots of the common difference. The penultimate plus sign. The penultimate term minus the common difference, and then that last term, un. Okay, so that is what we have. Now, let's write it again. You'll see why in just a second, but another way of writing it would be just to rearrange the terms so they're backwards. So I could have that one there, look. I could have un minus d. I could have un minus 2d, and so on and so on and so on. Here I'd have u1 plus 2d. Here I would have u1 plus d, and then finally I would have the u1. So all I've done there, I've just switched around the order. So why have I written it like that? Well, because what we could do is we could add those together. So on the left-hand side, I'd have two lots of s of n. But what's quite clever about doing this is on the right, can you see that if I add these two together and these two together and these two together and even these ones together, every pair, well, all of the common differences are going to cancel out. Okay, what's going to happen is I'm going to have u1 plus un, and I'm going to have another u1 plus un, and another u1 plus un, and so on and so on and so on. Okay, u1 plus un, right? So that is what is going to happen when I add those two together. Right. Okay, so that makes a lot of sense. So the question then is, I suppose, well, how many of these pairs do we have? Well, if we started with 1 and we ended with n, then we're gonna have n pairs, right? Or n of these. Maybe we should have n, just write the word n, right? There's n of these. Okay, right. So if we think about that then, well, that's going to mean that two lots of s of n is just going to be, well, n multiplied by u1 plus un. That's it. And so now if we divide everything by 2, we're going to have our first formula. S of n is equal to n over 2 u1 plus un. So this is really important. You get this in your formula booklet, and we're going to need to refer to this for all of the work on arithmetic series. But there is another formula as well, because we already have one for series. We already know that un equal to u1 plus n minus 1d. We know that from our work on arithmetic sequences, excuse me. So let's try and use that. What we can do is we can swap that in there for the un, and let's see what happens. So the sum of n terms of an arithmetic series is going to be u1 plus, well, u1 again plus n minus 1d. I'm replacing the un, and with a quick bit of simplification, we can get another final version of a formula. We're going to have two lots of u1 plus n minus 1d. So there is another formula there. So now we're going to have three different formulas that we can use for anything arithmetic. We've got two, look, these two, for the sum of the arithmetic series. And we've still got this one, look, this original formula for arithmetic sequences. And in the next video, we'll look at how we can apply these to help us solve arithmetic series problems.